Okay, we're going to look at some examples here, taken right from your textbook, Chapter 15, Section A, Example 1. And that is, if y equals 3x squared, subtract 4x, find dy dx. So dy dx, that's the derivative, would be 6x subtract 4. And also in this example, it asks exactly what does this mean? Well, this derivative means that the instantaneous rate of change of y with respect to x is 6x minus 4. Example 2. We have f of x equals 5x cubed plus 6x squared, subtract 3x plus 2, and we need to determine the derivative. This is the first. There's two parts to example 2. This is the first part. So take the derivative of the first term, so 15x squared. Add it to the derivative of the second term, so 12x. Add it to the derivative of the third term, negative 3. And the derivative of the last term is 0, so we don't need to put it in there. B from example 2, f of x equals 7x subtract 4 over x plus 3 over x cubed. Okay, keep in mind we could represent these x's in our denominator with negative exponents. So that is 7x subtract 4x to the power of negative 1 plus 3x to the power of negative 3. Now it's easier to take the derivative. We've got our exponents there. The derivative of 7x is 7. Derivative of negative 4x to the power of negative 1 would be positive 4x. Decrease the exponent by 1, so negative 2. Plus, no, it's not a plus, because 3 times negative 3 is negative 9. So it's subtract 9x, decrease our exponent by 1, so to the negative 4. And then just to represent this the same as the way it was represented in the question, 4 over x squared, subtract 9 over x to the power of 4. Example 3. Y equals x squared, subtract 4 over x. Okay, this question is very, very important. It's actually saying find the gradient function. So we need the derivative. Then find the gradient of the tangent to the function where x equals 2. Okay, I'm going to take my time here because this is very, very important, an important concept to understand. So I'm going to start by representing this with exponents for x to the power of negative 1. Okay, we can easily take the derivative, so dy dx equals 2x plus 4x to the power of negative 2 which is 2x plus 4 over x squared. Okay, we're looking at this function where x is 2. So if we think about what point that is on the graph of y equals x squared minus 4x, we can actually figure out what point that is by plugging the 2 in. So 2 squared minus 4 over 2, 4 minus 2, which is 2. So we're looking at the point 2, 2 on the graph y equals x squared subtract 4 over x. And we're trying to figure out what is the gradient of the tangent line at that point. Okay, so if we know the derivative, which we do, okay, so this is the derivative. If we know the derivative, we can then substitute in 2 into this derivative formula. So 4 plus 1, which is 5. So what this actually means is at the point 2, 2 on y equals x squared minus 4 over x, the slope of the tangent line is 5. Okay, very, very, very important. Please make sure you understand this concept. Okay, I'm going to do a little aside here. This is actually looking at similar questions to one of the questions that you will have in your exercise set. If we look at y equals x squared, you guys know what that graph looks like. It's a parabola. It's our basic parabola, y equals x squared. And we know a few points on this graph, 0, 0, 1, 1, 2, 4. And if we go further up, we would have 3, 9, and so on. Okay, and likewise over here, we have negative 2, 4. We have negative 1, 1, and we have negative 3, 9. Okay, so our function is x squared. We now know how to calculate the derivative of that function. It is 2x. What this actually means is, we can draw a little table here. I'll represent x and f of x, which is our y value. So this would be our ordered pairs here. Okay, so if x is 0, then f of x, our y, that point there is 0. If x is 1, y is 1. If x is 2, y is 4. If x is 3, y is 9. Okay, the derivative function, if we look at it, remember what the derivative means. It means it's the function that tells us what the slope of the tangent line at that point actually is. So if we look at the point 0 for x, and we drew a tangent here, well, that would be equal to the x-axis, wouldn't it? What's the slope of that line? We know that that slope is 0. Okay, if we substitute it 0 into this derivative function, we would get 0. Okay, actually it's this 0 that gets substituted in, but we end up with this 0. Okay, similarly, if we substitute in 1 into this function, we will end up with 2. What that means is at the point where x is 1 on the curve, the tangent line has a slope of 2. We can substitute 2 in to our function. We will get 4. What this means is at this point, x equals 2, the tangent, the slope of the tangent is 4. Again, substitute in the 3 into our derivative function, we get 6. What that means is at this point, where x is 3, the slope of the tangent line is 6. Very, very important concept. Probably the most important concept in calculus. And our last example for section A, example 4. Find the gradient function. In other words, we're finding the derivative of each of these functions. We're starting with f of x equals 3 root x plus 2 over x. Okay, so I'm going to represent this with exponents. This is 3x to the power of 1/2. So your algebra skills need to be fine-tuned in order to do calculus. X to the power of -1. Okay, so calculus honestly is not a super difficult subject, but it comes after all of the other high school math courses because you need to be proficient in all of the other high school math topics in order to do calculus. So here we're just looking at more algebra. All right, so the derivative function then. 1/2 multiplied by the 3 is 3/2. There's my variable. Decrease my exponent by 1, so that will be -1/2. Whoops, it's not going to be a plus, is it? Multiply the 2 by the -1. That'll be a -2. There's my variable. Decrease my exponent by 1, so -2. Let's write this a little more logically. 3/2. This would be times 1 over the root of x. Subtract 2 over x squared. So 3 over 2 root x. Subtract 2 over x squared. Okay, B. F of x, or g of x this time. Little change. G of x equals x squared. Subtract 4 over the root of x. So I'm changing that to 4x to the power of -1/2. And therefore, g dash x, the derivative of g will be 2x. This will be plus, negative times a negative, 4 times 1/2 is 2. There's my variable. Decrease my exponent by 1, so that's now -3/2. Now be careful simplifying this. 2x plus 2 over x to the power of 3/2. We can do better than that, I think. 2 over x cubed, which is square rooted, which actually equals 2 over x square root x.